Hi there! Before we begin this lecture, there are a few topics that are not discussed in my Chapter 1 lectures, so you'll need to review them in your textbook because they appear on Exam 1. Please take time to review the sections on necessary body functions and human body survival needs. You'll also need to know the 12 body systems, their functions, and their organs. These topics are pretty straightforward, and I've posted slides on the important information for them to your course space. That said, if you have any questions about them, please don't be afraid to ask. A few days ago, I was cooking a pot of vegetable soup for dinner. I generally taste my food as I cook, and this day was no different. I had finally gotten this pot of soup seasoned the way that I like it, but some of the vegetables weren't soft enough, so I let the soup cook a little longer. As I was waiting, I got a call from one of my good friends and was on the phone a bit longer than I had intended. When I went back to the soup, the vegetables were sufficiently soft, but the flavor balance was out of whack. The soup had become salty and very lemon forward. That is, it's too lemony. The flavor was off and the soup tasted terrible. So I did what any decent cook would do. I added a bit of baking soda to counterbalance the lemon and a bit of sugar to counterbalance the salt. Then I tasted the soup. Still too salty, so I added more sugar. Then the soup was too sweet, so I added a touch more lemon. This went on for several minutes as I tried to bring the flavors in the soup back into balance. The soup, in the end, wasn't exactly what I wanted it to be, but it did taste better, and I had a good dinner. It turns out that the human body does something similar. It tries to maintain the balance of certain internal conditions like your blood pressure, body temperature, and blood glucose levels, but it does it within a dynamic range of values in order to promote good health. This process is called homeostasis, and it's one of the most important concepts for you to understand in anatomy and physiology. When a human body does not maintain homeostasis, illness and unfortunately death can be the result. Let's take a look. By the end of this video, you should be able to define homeostasis and explain why it's important to supporting human life. You should also be able to describe what negative feedback and positive feedback are and how they maintain homeostasis. Finally, you should be able to explain the relationship between homeostatic imbalance and disease. Homeostasis can be defined as the maintenance of relatively stable internal conditions despite continuous changes in environment. But what does this really mean? You see, when the human body is functioning well, that is, it's in a state of good health, there are a number of factors or conditions that are maintained within a narrow range of values. We call these factors variables, and they include things like blood pressure, body temperature, respiratory rate, and blood glucose levels. So, for example, homeostasis tries to keep your blood glucose level below about 140 milligrams of glucose per deciliter of blood, regardless of whether you had a salad and chicken breast for dinner or 3 slices of chocolate cake. What, am I the only one who's done that? It also means that homeostasis keeps your body temperature around 98.6 degrees Fahrenheit, regardless of whether it is 20 degrees Celsius or 90 degrees Celsius where you're sitting. This slide gives you the expected values for blood glucose levels here, body temperature here, and blood pressure in a normal human being. Please make note of these as they could show up on an exam. When the human body cannot maintain homeostasis, disease, that is, a change from the state of good health, results, and in the worst cases, death can occur if homeostasis is not reestablished. So, for example, If a body doesn't maintain proper body temperature, let's say the body temperature goes from being 98.6 all the way down to below 95 degrees Fahrenheit, we call that hypothermia. Hypo means under, and thermia refers to heat or temperature. In this condition, the heart, the nervous system, and respiratory systems do not function properly, and people may show signs such as slurred speech, weak pulse, confusion, or memory loss. They may also show slow and shallow breathing. Too high of a body temperature, say above 99.5 degrees Fahrenheit, is called hyperthermia. Hyper means above, and thermia refers to heat and temperature. You might also call this overheating. Signs of hyperthermia include heavy sweating, rapid breathing, a fast and weak pulse, reddening of the skin, and dehydration. People with hyperthermia may also feel faint or dizzy, among other things. So in both of these cases, the body is diseased because it's not maintaining homeostasis and that normal body temperature of around 98.6 degrees Fahrenheit. Homeostasis is maintained by homeostatic control systems that are part of both the nervous and endocrine systems. The nervous and endocrine systems provide communication for monitoring and regulating variables in the human body. When the body is functioning properly and homeostasis is being maintained, body variables stay in their normal range of values, as represented by this flat board on the seesaw. When a change occurs in the body, we'll call this a stimulus. One or more variables may be thrown out of range. In order to restore homeostasis, three things have to happen. Number one, the body has to detect the change. Number two, the body has to be able to determine an appropriate response. And then number three, the body has to make a change in response to the initial stimulus, that initial change. Now let's take a look at how this happens. When there's an initial change, aka a stimulus, that occurs in the human body, receptors are the cells or the organs that detect that change. They will then send a message in the form of a hormone, that's a chemical, or an electrical impulse to another part of the body called the control center. The control center could be a cluster of cells or it could be another organ. And its job is to interpret what that stimulus from the receptor actually means. Then it determines what the appropriate response should be. The control center then sends another signal in the form of a hormone or an electrical impulse to yet a third location. This third location is an effector cluster of cells or an effector organ. The effector will cause a new change that will either counteract or reinforce the initial stimulus. This is called the response, and the main job of the response is to return the variable back to its homeostatic level. Negative feedback is the most common method that the body uses to restore homeostasis. You'll want to remember that negative feedback either reduces or shuts off the initial stimulus. Let's explore this method of restoring homeostasis by looking at how body temperature and blood glucose levels are maintained. Human body temperature is maintained at about 36.1 degrees Celsius to 37.2 degrees Celsius through the activities of the nervous system. When someone exercises a lot or sits in a hot room long enough, What happens? Their core body temperature will begin to rise towards the upper values of what is considered normal. This rise in body temperature is detected by special cells located in the brain and near the surface of the skin called thermoreceptors. In a homeostatic control system, these thermoreceptors would be the receptor cells. They detect that there has been a change in a homeostatic variable, and they're going to send an electrical impulse to the control center, which in this case is called the thermoregulatory center in the brain. The thermoregulatory center in the brain is located in a part of the brain called the hypothalamus. When cells in the hypothalamus detect that temperature is rising in the body, those cells send electrical impulses towards other organs called effector organs. In this case, your effector organs are going to be the sweat glands and the blood vessels that run near the surface of the skin. The electrical impulses cause these sweat glands to secrete sweat. Sweat cools the surface of the skin through evaporative cooling, and this helps body temperature fall. Those blood vessels that flow near the surface of the skin are stimulated by the electrical impulses to widen or dilate. This allows increased blood flow to the surface of the skin, and it allows the release of heat to the environment around the body. This helps cool the blood as it flows back towards the deeper parts of the body. Both of these effects, the sweating and the increased blood flow, cause the body temperature to fall, and this counteracts the initial stimulus of body temperature rising. So that's why this is called negative feedback. What happens when it's cold outside? When it's cold outside, body temperature falls, and this drop in body temperature is detected again by those thermoreceptors, those receptor cells near the surface of the skin and in the brain. They will send electrical impulses towards the thermoregulatory center in the brain. Remember, that's the control center of this homeostatic control mechanism. And those cells in the thermoregulatory center, aka the hypothalamus, they're going to send electrical impulses to other effector organs. In this case, it'll be muscles that are attached to our skeleton and those blood vessels that flow near the surface of the skin. The electrical impulses from the hypothalamus tell the skeletal muscles to shiver. Shivering breaks down ATP and causes the release of heat, which warms the body. The electrical impulses that are going to the blood vessels that flow near the surface of the skin tells them to actually constrict, to get smaller. This restricts blood flow to the surface of the skin, which causes the blood to cool, and it keeps the blood flow more insulated in the deeper core regions of the body. Between the insulation and the shivering, body temperature starts to rise, restoring homeostasis. So again, this is another example of negative feedback because the initial stimulus was body temperature falling, and through the effects of the effector organs, the shivering and the blood vessel constriction, we're going to raise the body temperature. Here is another example. During digestion, cells in our small intestines absorb glucose from the food that we've eaten. The glucose is then moved into our blood vessels and is transported throughout the body as part of the blood. A measurement of the amount of glucose in our blood can be taken using a drop of blood applied to a glucose testing strip or a glucose meter that you can find in any drugstore. A normal fasted blood glucose level of 90 milligrams per deciliter is maintained by a homeostatic control mechanism via the endocrine system. So, after we eat and digestion has occurred, thousands of molecules of glucose flood into our blood vessels. As a result, our blood glucose levels begin to rise. The rise in blood glucose levels stimulates cells that are part of the pancreas, these are called beta cells, to release insulin. Insulin is a hormone. There are receptors on the cells of our tissues and some of the cells in our liver that bind insulin. In our tissues, when insulin binds its receptor on a cell, it stimulates the cell to take in glucose. When liver cells bind insulin, they are stimulated to take up glucose as well, and to turn that glucose into a storage form called glycogen. The result of our tissue cells taking up glucose and the liver taking up glucose is that the amount of glucose in our blood begins to drop. So our blood glucose level declines back towards the normal set point of about 90 milligrams per deciliter. And when that happens, insulin release begins to taper off. And this helps to maintain homeostasis. Now, on the other hand, let's say instead of it being just after we've eaten, let's say it's been several hours since we've eaten. Well, the cells in our body are still absorbing glucose, so this means that our blood glucose levels begin to drop and drop and drop and drop. The drop in blood glucose level stimulates other cells in the pancreas called alpha cells to release a hormone called glucagon. Glucagon binds receptors on cells that are in your liver, and this stimulates those cells to break down glycogen. Remember, glycogen is that storage form of glucose. As a result, glucose gets released into the blood, and our blood glucose levels gradually start to rise. Once our blood glucose levels are back in the normal range, glucagon production tapers off and eventually stops. This helps to maintain blood glucose levels. So in both of these examples, our receptors and our control centers are cells located in the pancreas. They're just different cells. The effectors are also different. So in the case where we have rising blood glucose levels, the effectors are going to be the cells that are in our tissues as well as certain cells in our liver. In the case where our blood glucose level is plummeting, the effector is going to be cells that are in the liver. This process of adjusting blood glucose levels is an example of negative feedback regulation because the original stimulus, which is a change in blood glucose level, is reversed. Homeostasis is also maintained using positive feedback mechanisms. Unlike in negative feedback, positive feedback reinforces or enhances the original stimulus, and it may exhibit a cascading or amplifying effect. It turns out that positive feedback regulation is a lot less common than negative feedback. It's only used for infrequent events that don't have to be continuously adjusted. Two examples of positive feedback mechanisms include the enhancement of labor contractions by oxytocin and platelet plug formation in blood clotting. Let's take a look at them. When a woman is pregnant and the pregnancy is close to term, a baby orients itself normally such that its head presses against the cervix. So the cervix, you might remember, is the neck of the uterus. It's right here. That pressing causes cells that are in the wall of the cervix to begin to stretch. They're called stretch receptors. These stretch receptors send electrical impulses from the cervix to the brain, and they stimulate cells in the hypothalamus to release a hormone called oxytocin. So the cells in the hypothalamus become stimulated. They go all the way down to the pituitary, and it's actually from the pituitary gland that the hormone is secreted. Okay? But the hormone is called oxytocin. You might have heard this called the love hormone because it is involved in human bonding and well, love. So in any case, when oxytocin is excreted, it basically gets carried via the bloodstream to the uterus. In the uterus, oxytocin is going to stimulate uterine contractions. Those uterine contractions are going to move the baby towards the cervix, causing more stretching of the cervix. As this happens, more nerve impulses go up to the hypothalamus and stimulate the secretion of oxytocin from the pituitary. That oxytocin enters the bloodstream, and it comes down to the uterus and stimulates more uterine contractions. Those contractions again cause the baby to move towards the cervix, which causes more stretching, which causes nerve impulses again to go towards the brain, stimulating the release of oxytocin, which goes through the bloodstream to the cervix and stimulates more contractions. So this kind of cycle happens over and over and over again until the baby has been born. It's passed through the cervix, and those stretch receptors that were being stimulated are no longer being stretched. This is an example of positive feedback because the initial stimulus is the stretching of the cervix. It's enhanced by the oxytocin release, which causes uterine contractions that help push the baby towards the cervix and cause more stretching. When we get a cut or a scratch, we often bleed as blood leaks out of blood vessels near the cut. Platelets, which are basically cell fragments, will begin to stick to the cut. As they do this, they will release chemicals that attract more platelets to that location. As those new platelets arrive, they begin to stick to the cut, which stimulates the attraction and the adhesion of still more platelets to the cut, which causes the release of more chemical attractants, causing more platelets to come and stick to the cut. So this happens over and over and over again until finally the cut or the tear in the blood vessel is plugged up and we have the formation of a clot. This is again another example of positive feedback because the initial stimulus is the adhesion or the sticking of platelets to the cut, and that continues to happen until the cut is sealed. There are a number of misconceptions about homeostasis. One misconception is that negative feedback is bad and positive feedback is good. So when people hear the word negative, we automatically think of bad consequences. And when we hear the word positive, we think of good consequences. But in the case of negative feedback and positive feedback, we're only referring to the direction of output. Okay, the direction of output in response to an initial change. Normally, both negative feedback and positive feedback promote homeostasis. A second misconception is that maintaining homeostasis means that the body's internal environment is static or unchanging. You know now that this isn't true. When you eat, your blood sugar levels and levels of other nutrients increase, and when you haven't eaten in a while, those things decrease. You also know that the levels of other chemicals in the blood change. Your digestive system undergoes multiple physiological processes to digest food. Your temperature changes throughout the day. It turns out that homeostasis and these kind of regulatory mechanisms have to continually be in play to keep our variables within range. Misconception number 3 is that regulatory mechanisms like these feedback mechanisms we've talked about, they're either on or off, like a switch. But it turns out that since the internal environment of the body is a dynamic place, these feedback mechanisms are constantly engaged to some degree of activity. So your blood sugar, for example, is constantly being adjusted and changed so that the body can maintain that can maintain that 90 milligrams per deciliter value. Misconception number 4 is that any physiological variable can be controlled. It turns out that in order for a variable to be regulated by negative and or positive feedback, there has to be a receptor that detects changes in the set point. For some physiological variables, there is no receptor, and so those cannot be regulated by homeostasis. Just as an aside, changes in an unregulated variable can disrupt homeostasis for a regulated variable. When we talk about vitamin D and vitamin D deficiencies, we may touch upon this topic. So what happens when the body cannot maintain homeostasis? Typically, the result is disease. Disease is defined as a change from the state of good health. Examples of disease that can result from homeostatic imbalances include cancer, diabetes, chronic inflammation, and asthma, among others. Homeostatic imbalances also contribute to the changes associated with aging because as we age, our homeostatic control systems become less and less efficient. In the case where negative feedback mechanisms become overwhelmed, that is, they cannot restore homeostasis, positive feedback mechanisms can take over, which can lead to severe damage to body tissues and structures. An example of a disease that's caused when this happens is heart failure. Now let's see what you remember. What is the definition of homeostasis? Is it 1. The ability to maintain relatively stable external conditions even though the inside world changes continuously? Or is it 2. When the output shuts off the original effect of the stimulus? How about 3? The response enhances the original stimulus so that the response is accelerated. Or 4. The ability to maintain relatively stable internal conditions even though the outside world changes continuously. Pause the video and join me when you think you have the right answer. Did you say number 4? I knew you knew this. You're right. Number 4 is the ability to maintain relatively stable internal conditions even though the outside world changes continuously. Let's try another. Which of the following is an example of a negative feedback mechanism? Is it number 1, during labor, as uterine contractions begin, levels of the hormone oxytocin continuously rise to further stimulate more contractions? Or 2, the thyroid gland secretes thyroid hormone under the influence of the hormone TSH. TSH release decreases when thyroid hormone levels reach their set point. Or 3, an individual who is incapable of synthesizing thyroid hormone will often develop an enlarged thyroid gland due to continuous TSH stimulation. Pause the video and join me when you think you have the right answer. Did you say 2? 2 is the right answer here. The thyroid gland releases thyroid hormone under the influence of TSH. But when thyroid hormone levels reach their set point, that is when they're back to normal, then TSH release decreases. Which of the following would be considered a normal fasted blood glucose level? Is that 140 milligrams per deciliter or 60 milligrams per deciliter? How about 92 milligrams per deciliter or 200 milligrams per deciliter? Did you say 92? You are correct. Remember, your average fasted blood glucose level is around 90 milligrams per deciliter. You might be wondering what I mean by fasted. Fasted means that someone has not had a meal for at least 2 hours. Which part of a homeostasis control mechanism receives input from the control center and provides a means of response? Is it the control center, the effector, or the receptor? Effector, that's right. The control center sends output, which is received as input by the effector, and the effector provides a means of response to the initial stimulus. Great job! So this brings us to the end of this topic. Homeostasis is the maintenance of stable internal conditions, regardless of what's happening externally. Certain variables are maintained within a dynamic range of values by negative feedback and positive feedback regulations or mechanisms. The big difference between the two is that negative feedback reverses a change that has occurred, whereas positive feedback enhances that change. Homeostasis is normal and essential to human survival. When homeostasis is not maintained in the body, diseases like heart failure, diabetes, and cancer can result. Thank you for watching this video and taking notes. In my next video, we will cover topics about cells that are important in A&P, but you may not have covered all of them in your last bio class. I'll see you then.